Today I'll be installing this motherboard from Lerdge onto my 3D printer. It comes with a touchscreen, which I've installed into this panel, and it has 6 stepper drivers and a bunch of inputs and outputs for advanced features. One of the nicest things about this motherboard is you can set it up and change virtually every setting just using the touch interface here. So I can change between having a standard printer configuration, or a Delta printer, or a Core XY printer. Those are some pretty advanced options that I can just change through the menu here. So that pretty much eliminates the need to ever go into the firmware and recompile code and flash the firmware onto these motherboards. Honestly, a lot of people don't know how to do that, and it's really easy to mess your printer up that way. So having everything easily accessed through here has some serious advantages. In my case, I need to upgrade to this mainboard because I'm using 2 separate heat blocks with 2 different thermistors and heater cartridges, but the stock board for the Ender 3 V2 doesn't support having multiple hot ends. So the first thing I'm going to do is get this mounted underneath the Ender 3 V2 where the original mainboard is. So I'm inside of the motherboard compartment and I'm just going to unplug everything and remove all the screws so I can take the old motherboard out. Alright, with the old motherboard out of the way, let's start looking at ways I can mount this Lerdge board. So it looks like it's too big to fit in here. So what I'm going to do is just cut this piece of sheet metal up at the top and fold it upwards to give me some more real estate down here. And then I'll just attach this down at the bottom. Let's see, I'll fit it right here. So I'll just cut it right here, right along the edge of this little ear to the side of the SD card. Okay, now that I've made that cut, I'm just going to fold this up. Alright, now to flatten out this sheet metal, I'll just hammer this. Now I'm just going to clean this area up with a Dremel. Now I'll just mark the 5 locations of the holes I want to make, and then drill them out. Alright, so now this is bolted into place, and I can start rewiring everything. Alright, so I just finished wiring up my new Lerdge mainboard. Some of the tricky parts were I have 2-pin limit switches instead of 3-pin. These boards are built for a 3-pin limit switch, but you can just plug them in like this using these 2 lower pins and leaving this top pin bare. I don't think this board can deliver enough current to power the heated bed, so I also had to wire in a bed control MOSFET. It gets the signal from the usual spot on the main board, but it delivers the power directly from the power supply over to the heated bed. So everything's all wired up. I'm going to flip this right side up and see if I can get it running. Alright, so I have no idea if this is going to work. First step to get it working though is to turn it on and make sure nothing's smoking. Alright, this is pretty good. I'm getting readings from both of my thermistors, both on the heated bed and on the hot end. First I'm going to home the machine and see if it'll work. Make sure I set my switches up correctly. Uh-oh, it's going the wrong way. So I'm going to have to configure it to switch the X and Y axes around because it's going backwards right now. Alright, so the setting is in Settings, Motor, Direction. So I need to switch the X direction and the Y direction. Let's try homing again. I might also need to switch the Z direction or some of these extruders, but we'll see how that goes. I'm going to try and home it again. Okay. So it clearly wasn't listening to my limit switches there. I might need to switch it from a normally open to a normally closed type sensor. So we go here, structure, standard XYZ, home position, advanced setting, end stop setting, normally closed, normally closed, normally closed. Alright, we'll try that again. Home. Yep, that worked. Yep. Ooh, yeah, that all works. Okay. So that's all fine and dandy. I'm going to test the extruder, make sure it's rotating in the correct direction. So in order to do that, I will go to movement settings and I'll move the extruder in the positive direction. Okay, so that's backwards. That means I need to go into here, change the motor direction. I need to flip the extruders around too. Okay, yep. Extruder is going in the correct direction. So you can see here, Hotend 0 is reading a temperature, which means that our thermocouple is hooked up correctly. Hotend 1 is also reading a temperature, so we've got thermocouples on both of those. That's a good thing. So I just set it to preheat PLA. The top heater block is heating up, and this bottom one isn't. But the good thing is that the temperature reading is showing up there, which means I've got the right thermistor hooked up to the right heater cartridge. I guess that means I'm ready to slice some stuff and start printing, so let's get to it. Alright, I'll plug in this little SD card. It's got my new code on there. So now I'll just try printing that code and see what happens. I really like this user interface. It's super snappy. And I can use both the touch screen or the scroll knob here. So, Octopus Planner, dual extruder G-code. Start printing, yes. Alright, so it looks like the second layer went up too high. So I need to adjust my Z-steps. Just looked it up and my Z-steps per millimeter is 400 on an Ender 3. But for this machine it was set up by default to 800. So it went up twice as far as it was supposed to. Well, this print was looking pretty good, but it looks like it bumped into something and it skipped some steps. So now I have an offset and it's not printing in the right spot. Also, I noticed my belt came loose. It's just not as tight as it was before. And if I look back at the stepper motor here, it looks like it's come loose from this plastic housing. So after looking everything over, I'm pretty sure what happened is that this part melted because the stepper motors were overheating. And something I neglected to do after installing this new mainboard was to check the VREF voltages, which determine how much current gets sent to the motors. And if you're sending too much current to too small of a motor, it'll get really hot. And in this case, it must have melted the bracket that it was holding onto. There's a little screw potentiometer right here that I can turn, and that'll adjust how much current gets sent to the stepper motors. The Y motor tends to run a little hotter than the rest of the motors because it's right underneath the heated bed. So it's being heated up from the motor current, and it's also being heated from the heated bed above, which is in close proximity to it. A little trick you can do is hold the positive terminal onto the screwdriver itself, so I'm touching this to the handle with my thumb, and negative to negative there. Alright, now I can adjust it and see the live updated results. So I want to be about 0.9, 0.8, yeah, we'll do 0.85 there. All of these X, Y, and Z axes need to be set. I'm aiming for about 0.65. Alright, there we go. So I shouldn't have any more overheating stepper motor issues. I was able to put this back on in a really hacky way, so I just put some longer screws with washers in there so they sit on a different part of the housing that's not melted. So I'll just get that reinstalled and we'll get to printing again. Alright, so we should be good to print now, so I'm just going to start up my program. I received this filament from Duramic 3D, so I'm going to try it out and see if it's any good. It looks like I might need to adjust the retraction settings there, but we'll let it run. That's pretty bad stringing. Alright, it looks like I'm getting some pretty bad under extrusion issues. So I'm going to go ahead and put a dual gear extruder onto this thing. just so that I can push that plastic through a little bit faster. Looks like this filament has really good bed adhesion, so I don't have to worry about it coming off mid-print. So I just finished installing this direct drive extruder, and I'm going to need to change a couple of settings in the printer's software so that it knows that it's running this different extruder. First, I'm going to see if it's extruding in the right direction, so I'm just going to go into Settings, Movement, and have the extruder back out. Alright, it's moving in the right direction, and now I just need to make sure that its E-steps are correct. So since this extruder has a gear reduction, the E-steps will probably be pretty different. Sounds like someone else was using 423.25 for their settings, so I'll enter those in here in motor, step value, E-steps, and 423.25. Now that I have a dual gear direct drive setup, I should get a lot more consistent extrusion because I have a lot more traction to push that filament through the machine. Alright, we're starting the first print with this new direct drive extruder. It looks like it's working great, and it's able to push that filament through a lot faster. I'm just going to add a little grease up here. Alright, now we're on the second layer and we've really picked up the pace. You can see that wheel spinning around real fast. Alright, so it looks like we're finally past the solid infill stage. And I think right now it's actually over extruding a little bit. Alright, so as you can see, this print is coming along really nicely now. That dual extruder upgrade, direct drive, really improved things. So I'm no longer having any under extrusion issues. And also, this filament, which I thought was kind of delicate when I was dealing with a single extruder, is working a lot better now. There's no grinding of the filament, it's just all going straight through there. Alright, and we're finishing up the last layers on this print. This was printed in 2 hours and 42 minutes. Very nice. I really like this filament that I got. It's got this nice matte surface finish. Looks like it held onto the build plate really well. I really like this gray PLA because it has excellent bed adhesion, and the surface texture is something else. So it's kind of easier on the eyes. You're not so distracted by the reflections, and you can see the shape of the object you've printed. Also, this matte finish PLA has more of a texture to it. So when I touch this glossy stuff, it's kind of a slick finish, and the matte finish is more like a, it's just a little grippier. So if you're making something like tool handles, this matte finish could come in quite handy. This might be the most expensive Ender 3 that I've ever seen. I've just thrown a lot of expensive upgrades on this really simple machine. But hopefully I've given you some idea of, some upgrades you might want to add onto your 3D printer at home. I also like how responsive the touchscreen is here. Like, I just touch things and it goes there right away, and I can change settings. I don't have to double check if I pressed a button. It's all just really fast and responsive, so I really like this Lerdge control board. If I were building a printer from scratch, I'd probably get one of these just so that I don't have to deal with firmware. So thanks for watching this video. If you guys have any ideas of what I should add to this machine next, or how I could use this Hotend heat gradient, let me know in the comments below, because I know there's a lot of things I could do with this, but right now I've just set them both to the same temperature because that just seems like the easiest thing to do. But I can individually assign temperatures to this. So for instance, I could have this be like 260 degrees up at the top and 220 degrees down at the bottom. I'm not sure what the implications of that would be. Maybe I'd get better retraction performance. I'll leave descriptions to all of the products that I used in this video in the description down below. So thanks for watching, everyone, and I'll see you in the next episode.